Hey, I'm Shane, and in this video, Nabil and I are going to be discussing UV rays. In 1801, a scientist known as Johann Ritter discovered the existence of ultraviolet rays. He discovered the UV rays by comparing the effect that different color light exposure had on photographic paper. UV rays produce an invisible light that is otherwise known as black light. Police forensic teams are able to utilize black light to discover hidden evidence at scenes of crimes. As well as police, bees are able to utilize the light that is produced by UV rays. They use it to guide themselves to sources of pollen. The excessive presence of UV rays on photographs causes photoaging, which cosmetically alters the photos to make its subjects captured appear older. The amount of UV rays one is exposed to is not mediated or affected by the temperature, so one is able to acquire sunburns even on a sunny winter day. UV rays are mostly capable of traveling through glass barriers, such as windows in houses or cars.
Ultraviolet or UV light in the electromagnetic spectrum falls in between visible light and X-rays. It has frequencies of about 8 times 10 to the 14th power to 3 times 10 to the 16th power hertz, and wavelengths of about 380 nanometers to 10 nanometers. According to the U.S. Navy Ultraviolet Radiation Guide, or UV Radiation Guide, UV is generally divided into 3 subbands: UVA, UVB, and UVC. UVA, or near ultraviolet, is about 315 to 400 nanometers. UVB, or middle UV, is 280 to 315 nanometers, and UVC, far UV, is 180 to 280 nanometers. The guide goes on to state that radiation wavelengths between 10 nanometers to 180 nanometers are sometimes referred to as vacuum or extreme UV. So anything below UVC is referred to extreme UV. These wavelengths are blocked by air, which means the Earth's atmosphere interferes with them, preventing them from coming in and harming us, and they only propagate in a vacuum. There are many uses for UV or ultraviolet light. Hospitals use UV ultraviolet lamps to sterilize surgical equipment and air in operating theaters. Food and drug companies use ultraviolet lamps to sterilize their products. Suitable doses of UV rays can cause body to produce vitamin D, and this is used by doctors to treat vitamin D deficiencies and some skin disorders. We have 2 questions that need to be solved for ultraviolet rays. First question is, if an ultraviolet ray has a frequency of 1 times 10 to the 16th power hertz, now how long is its period? Second question is, a wave of the same frequency of 1 times 10 to the 16 hertz and a wavelength of 1 times 10 to a negative 8th power, what is its velocity? Let's do question 1. Question 1 is asking for the period. So we would use the formula T is equal to 1 over F. F in this case would be frequency. So this would look more like this. T is equal to 1 over 10 to the power of 16. Then all you gotta do is do the math. The answer for this equation is, we're asking for T, so T is equal to, let's put in your calculator, is equal to 1 e negative 16. And so now, let's do question number 2. Question 2 is giving us the frequency, which is 1 times 10 to the 16th power, and the wavelength, which is 1 times 10 to the negative 8th power. And it's asking us for the velocity of the wave. For this one, we would have to use V is equal to F, which is frequency, times lambda. Lambda stands for wavelength. So the equation would look like this. V is equal to 10 times at the 16th power times 10 to the negative 8th power. Frequency times wavelength. The answer, which is looking for velocity, would be putting it into your calculator, and it would be 1 along with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Which you can put this into your scientific notation as 1.0 times 10 to the eighth power. So your answer is for question 2, the velocity of the wave is 1.0 times 10 to the 8th meters per second. And the answer to problem 1 was 1e negative 16 seconds. This information is definitely trustworthy. This information has came from 4 websites and 3 books, which have been cited. The 4 websites are livescience.com/5032/what-is-light.html. Second source is www.darville.claire.net/emag/emaguv.htm. Third website is http://ems/10_ultravioletwaves.html. The fourth website is science.hq.nasa.gov/kids/images/ems/uv.html. Also, the two books were the following. One being 4th edition, AP edition, physics textbook by James S. Walker. And the second book is Essential Physics, page 637 and 638.